Graphs of rational functions. So for number 1, it wants us to sketch the graph of the rational function. So let's zoom this in to take a closer look at it. So we need to find the vertical asymptote first. Remember, a vertical asymptote is a vertical line where the graph approaches it but never ever touches it. To find it, set the denominator equal to 0. So in this case, the vertical asymptote would be -4. So zooming this back out, we need to find the one of these that has a vertical asymptote of -4. So that could be, let's say, here or here. Let's make this one larger. So this would be 2, 4, -4. So that's the vertical asymptote here. Clicking this one, we also had the vertical asymptote of -4 here. Remember, these go by scale of 2's. But now we got to figure out which one of the two it will be. So we're going to have to find the horizontal asymptote because each of these has one of those as well. So zooming this back in, we look at the variables. Normally we would see which one has the highest exponent. Here their exponents are the same. So what we're going to have to do is divide their coefficients, which the coefficients of each of them are 1. So 1 divided by 1 is 1. So that means there is a horizontal asymptote of 1. So zoom this back out, looking at C, and this does have horizontal asymptote at 1. Looking at D, its horizontal asymptote is at -1. So that means C is going to be our answer. And that's number 1. So number 5, what would be the domain of a rational function? That would be all real numbers except the ones that make the denominator 0. So that would be C. And that's number 5. So going to number 7, all the values that make the expression undefined would be the numbers that make the denominator 0. So set n plus 2 equal to 0, and that'll give you -2 for n. And that's number 7. Going to number 14, the graph of a rational function f is shown in the figure. Use the graph to find a function of 4. So that means where 4 is x. So going to 4 is x, that would be 4 for y. So function of 4 would be 4. And that's number 14. Number 16, find the domain of the following rational function. To do that, set each of the expressions in the denominator equal to 0, and you'll get 8 and -9. So the domain is going to be all real numbers except 8 and -9. And that's number 16. Number 17, graph the rational function. So zooming it in, we need to find our asymptotes first. So for the vertical asymptote, set x plus 2 equal to 0, and you get x equals -2. So it's the vertical line x equals -2. For the horizontal asymptote, our variables have the same exponent, so divide the coefficients. This has a coefficient of 1, so 2 divided by 1 is 2. So the horizontal asymptote is 2. So now let's look at our graphs and see which one will be. So looking at A, it does have the vertical asymptote of -2, but its horizontal asymptote isn't +2, so it can't be A. Looking at B, B doesn't have the vertical asymptote at -2, so it can't be B. Looking at C, it also does not have the vertical asymptote at -2, so it can't be C. Looking at D, not only does it have the vertical asymptote at -2, it also has the horizontal one at 2, like we're supposed to have. So it will be D. And that's number 17. Number 19, find the indicated intercepts of the graph of the function. So it wants us to find the X-intercepts. So zooming this in, now the X-intercepts are where y is 0. So basically we're finding where this whole function equals 0. For that to happen, the numerator has to equal 0. So you set each of these expressions equal to 0. So setting x minus 5 equal to 0, you get x is 5. Setting 2x plus 5 equal to 0, you subtract 5 and divide by 2, and you get negative 5 over 2. So those are the x's, and their y's will obviously be 0. So A would be my choice. And that's number 19.